Okay, so topic 5. Need your attention up here, please. A few more identities that we're going to be using today. So you had the angle sum identities on page 618. You're supposed to answer question 1. So those were your angle sum identities. A few things to note. Sine A plus B. That means angle A plus angle B. So that would mean if you take the sine of angle A times the cosine of angle B plus the cosine of angle A times the sine of angle B, you'll be able to find that sine value. And same thing for cosine. Just note the difference here. Sine has sine A cos B and then cos A sine B. Cosine has cos A cos B. They're the same. Same trig function you're using here. And sine. And notice this says plus. It goes with plus. And cosine actually is minus. And we'll actually go through at some point, not today, just so you have time to work, but we'll go through and we can show how these identities, how we come up with those identities. But for now, you need to memorize them. You're going to use them on Friday's quiz. Okay? You'll be using them as you work to simplify different equations or different expressions there. We use them when we don't have special angles. Like, for instance, cosine 105. That's not a special angle. We can write it in terms of special angles. Okay, cosine 105, those two special angles that add up to 105 are good, 60 and 45. So we have 60 plus 45. Okay, this would be considered A. That one would be considered B. All right? So we could rewrite that now using this identity. So cosine of A plus B is equal to cosine A, or 60, times cos B, or 45, minus sine A, or sine 60, times sine B, sine 45. And then calculating that out, we should know what the cosine of 60 is. What's that? 1/2. So you got 1/2 cosine 45, root 2 over 2. Sine 60 and sine 45. Okay, we multiply it out, root 2 over 4, root 6 over 4. And then, can we actually subtract root 2 and root 6? Can I subtract root 6 from root 2? Get negative root 4? No. Remember, with radicals, to simplify them, have to be the same root. You treat them like variables. Okay? So this would actually equal root 2 minus root 6 all over 4. I don't know why I put sets there. There we go.
You can enter that calculator to find the decimal value.
Yeah, and in fact, if you put this into your calculator and then put cosine 105 in there, you should get the exact same value. Yes?
How do you come up with the 60, like the A and B angles to use?
Well, I chose special angles, like so my 30, my 60, my 90, 45, 360. I'm choosing special angles.
What if you can't use special angles?
You want to choose angles that are in like the circle?
Correct.
Oh.
What if you can't use special angles?
Then you're not going to use that identity.
Is
Yeah.
there another one?
There are a lot of identities. Yeah. Yes?
Does it matter if it's like if 60 is A and 45 is B?
Doesn't matter. You can add in any order. It'd be okay.
Geometry all over.
Other questions? Good questions. Okay, let's try this here. I want you to now take out your graphing calculator. Make sure you set it to these settings. Okay, and then calculate these values. Find the value of y when theta is 45, negative 45, 90, and negative 90. Okay? Sine of 45.
0.71.
Okay. Sine of negative 45.
Negative 0.7.
Sine of 90.
1.
Sine of negative 90.
Negative 1.
Therefore, the sine of negative theta is equal to
Oh, equals, negative.
negative sine theta. Sine of negative theta is equal to the sine of theta, just with a negative sign in front of it. Negative sine theta. So if I were to calculate sine theta, sine of 45, to get 0.7, to get the sine of negative theta, or negative 45, I'd put a negative sign in front of that. Okay? We'll see that visually here in a minute. But before, what's that?
The sine of 45 is equal to negative the sine of 45?
Correct. Yep. Alright, I want you to try the same thing, same settings for your calculator. However, now we're going to deal with cosine. So, here's theta,
But then it's minus.
and I want your y value there. Okay? Alright, go ahead, what's this one?
0.7.
0.7? Here?
0.7.
Negative.
Negative 0.7.
Negative. Negative.
Negative 0.7.
Okay, so if I have cosine of negative theta, how does that compare to cosine theta?
It equals cosine.
They're the same, right? So when I take the cosine of positive theta, that's equal to the cosine of negative theta. So cosine negative theta is equal to
What?
positive cos theta, or just cos theta. Alright? So now if you think about, well, first of all, there are your identities, the negative angle identities. Sine negative theta equals negative sine theta. Cosine negative theta is equal to negative cos theta. Alright? When you start thinking about that in terms of a unit circle, you think about, say, 30 degrees. If I put 30 degrees in, and I'm dealing with sine, what's the angle measure for 30 degrees for sine? Or excuse me, what's y equal for sine 30?
1/2.
It's equal to 1/2. Now when I go down and do negative 30, I'm now equal to
1/2.
Negative.
Negative 1/2.
negative 1/2. Note where it hits the y-axis, right? Okay, it changes. It goes from positive to negative. And if I'm dealing with cosine, the cosine of 30 is root 3 over 2. It's right there. Well, that's directly below, or directly above, however you decide to look at it. That's also root 3 over 2 when it's negative 30. So it doesn't change. That's pictorially what we're dealing with when we're dealing with these. Okay, if you want to think of it in a graphical form, this is your sine curve. When I have sine of theta, say, if I want the sine of 90, the sine of 90 is, or excuse me, I just did that wrong. There's sine of 90. Sine of 90 is
There.
1. Sine of, there's 180, there's 270. Sine of 270 is
Negative 1.
negative 1. Well, sine of 270,
Equals.
think
sine
of that 270 degrees. How far is that from 360 on the unit circle?
90.
90 degrees. It's going this way. So this is negative 90. Okay? And we're dealing with, if I'm going backwards, I'm here.
And that's one period.
What's that?
That's one period.
Yeah, that is one period. Very good. Okay? Any questions there? You think we have it? Okay. Yeah.
If it's if the graph is 2 periods, if it's 2 periods between 0 and 2 pi,
Uh-huh.
then between negative 90 and 270, would there be 2 periods or just one?
Negative 90 to 270. That's one period. Like, it really to actually show this accurately, we should continue this back and go to negative 270. right, which would be right there. That would be negative 270, which would bring us to positive 1, right? So you're at 1 there, you're at negative 1 here. Okay? The sign of positive 270 is negative 1. The sign of negative 270 is positive 1. They flipped. We get that? Even though this is, when you're going back 90, okay, that equals that 270, but you've got to go back that whole rotation to get to 1 there.
So that's why you call it a 90-degree shift when it's cosine sine.
Correct. Yep. If you're dealing with cosine, you kind of think of it the same way. If I'm, say, I actually got to extend this one up as well, so let's extend that. It's a poor extension of it, but that's okay. All right, this point right here, actually, let's use a point. Let's use that. So that's cosine of 360, right? Okay, which is 1. Negative 360 is negative, or is also positive 1. Okay, so it doesn't matter if you go back 360 degrees or forward 360 degrees, you'll be at the same point. Versus here, when you go back 270, you're at a positive, and here you go forward 270, you're at a negative. Okay? All right. Hey, it's nice to know pictorially what's going on. Real quick, the derivation of the angle differences. So we've got angle sum, we have the negative angles, and now we have the angle differences we're dealing with. Okay? I want you to read about it, and then try number 6. Talk about it, so we could get it.
You're plugging in negative b.
Substitute negative b for this identity, cos A plus b. So if I take cos A plus b, and I put negative b in, that now gives me cos A
Minus b. Okay.
cos A plus negative b, right?
Which is a minus b.
Which is cos A minus b.
You push it.
What is cos A plus b? Go ahead, Connor.
Cos A plus b equals cos A times cos b minus sine A times sine b.
Okay. Sine b. That's our angle sum identity, right?
No, it's angle sum.
That's angle sum. Okay. Now when we put in negative b, we put in the opposite of b for b, so we replace all those b's with it. Okay, and we keep going through that. We know that cos A times, what's cos of negative b? Use your negative angle identity. That's cos b. It's just cos b. Okay? Minus sine A. What's the sine of negative b? Natasha? Good. That's equal to negative sine b. Right? We're using those negative angle identities. So we have cos A times cos b. Remember, cos negative b is cos b, using our negative angle, minus sine A times negative sine b. You can think of that negative sine b as like being negative 1 times sine b. And that negative 1 can be pulled out to the front, right out here. You can multiply in any order to actually make that. What's that become then? That becomes a plus. Which is this identity right there. The angle difference identities there. They did that in the previous, or in the book for sine A minus b. Okay, so the angle difference identities, notice they're They're similar to the angle addition identities, just this one's now minus and that one's now plus. Okay, and the cosine ones are they're kind of backwards from what you'd think. Need help, McKenna? You got it? Okay. Hayden, how are you?
I'm alright.
You should sleep at home. It's good stuff. It's more comfortable, probably. Alright. Hey, let's try number 7. Here's number 7. For those of you that will look at this and struggle, let me give you a hint for the sake of time as well. That's A, that's B. Okay? Here we go.
That's not that funny. It's like this thing's building up.
Hold on, chapter. You didn't hear that.
Hear what?
Nothing.
Was it like this?
Like,
Like from Mr. Logo's room?
yeah.
I heard that.
Okay.
Okay, there we got it. Sine theta minus 90 is equal to negative cos theta. For those of you who have really tried to, as we've went through this stuff and tried to tie this to your pictures, and you try to think about what they're actually saying, when you're looking at a sine curve, right? If I take my sine curve, okay, so I've got a sine curve. I don't know why I always have issues. What's that? Golly. Hey, bunch of critical people, man.
Yep.
Never be good enough.
Yep.
I'll never live up to their standard.
Yep.
It's kind of a bump at the.
Yeah, I don't want to hear it. Okay? All right. If I'm at theta and I subtract 90, all right? So let's say I take and do an H shift of 90 degrees. That's what that is, right? Which means we move this way 90 degrees. So think of this point. That's 90 degrees, right? So if I actually continue this curve this way, now I know I'm going to offend some of you with my drawing.
It looks beautiful. It looks beautiful.
Right.
It looks beautiful.
Thank
I'm
you.
offended.
Thank you.
I
Okay.
I was like, oh,
Connor gets an A.
Why do white girls
Hey, 90 degrees. If I do a 90 degree shift, stay with me, please. If I do a 90 degree phase shift this way, this point now is right here. Okay? And as I start cruising through and doing that graph, you're getting me distracted. Okay? As you go through and start dealing with that graph, you end up with your cosine curve, your negative cos curve. Yeah, you could. That'd be cool looking. Little slide. Is that what you're talking about? Yeah, 3D slide. Cool, but that's not the point. This is a cosine curve. Negative cos. Negative cos after you shift that sine 90 degrees. Okay, I've about lost you, so we have to do our last thing. Rocky. Okay, hold on. What's that? Hold on. Hey, guys, get a clue, man. Whoever's talking back there. I can't hear anything.
You're gonna play Clue?
Unbelievable. Lean this way. Pay attention. Go ahead.
I don't understand the equation, like how you got to where you got the equation.
How I got this equation?
Yeah.
So
How you got,
this is our A and our B. We used our sign difference identity here. And so we plugged in A We just plugged in our A's and B's for,
But I don't understand how you got negative cosine.
so sine theta, cosine of 90 is 0. Cosine theta, sine of 90 is 1.
Oh.
And so that multiplied together gives you negative cos. This multiplied together gives you 0.
Gotcha. Okay.
Okay? Okay. Yeah.
Why don't you use negative?
0 is nothing.
Okay, if you're talking, stand up, put your finger over your mouth, and start walking towards the door, please. You can stand out there. Go ahead.
Oh, why don't you use negative 90? Is it just because it's an H shift, so it's whatever makes it 0?
Right here.
Yeah.
Yeah, it's an H shift. Yeah, it's whatever makes that 0. It's the same thing as an H shift. Yeah. Other questions? Good question. Hey guys, when you're talking, there's two things you have to remember. First, if you get it, the people around you that do not get it, they can't hear. And so that's called being rude if you haven't figured that out yet in life. The second is, the person up here that's trying to explain it, I can't focus. The older I get, the less focus I have. Okay, it's like a sine curve. Okay, I was at the peak, and then all of a sudden I'm starting to drop back down for some reason. I don't know what's up. You don't have focus right now. You're like at the bottom of the curve. You guys right here, put your hand down. He's talking about clue and stuff. No. Okay, number 10. All right, everyone give that one a shot. Best you can. Write tangent in terms of sine first, please. You have it copied down. It's been pointed out by the fact checker there. That's page 620. Okay. Use the angle difference identities for sine and cosine to find the exact value of tangent negative 300. So first we have to think that tan negative 300 is equal to sine negative 300 over cosine negative 300. We know that sine over cosine is tangent. And in that case, if we can think of sine negative 300 in terms of a difference, or sum. In this case, I'm going to say it's 60. Let's go sine 60 minus 360. You can use you can use a bunch of different options there, but the sine of 60 minus 360. And so we'll go cosine 60 minus 360 as well. That means this is A, this is B. So now I'm using the angle difference identity. So that's the sine of A cos B minus cos A. Oops, I put B. Actually, should have been 360. Sine B. Over. If I could write what? I can zoom in a little. How's that? Thank you for being so polite. That was such a nice way there. She didn't demand.
Right bigger.
Yeah. Well, now she demanded. Oops. That's sine. Okay. So we substituted all that stuff in. I like to think of each of those as a little problem. Like sine 60. I like to think of that as an individual piece. That's root 3 over 2. Cos 360 is, or cos 0, 1. Okay. Minus cos 60, 1/2. Sine 360, 0. Okay. So those pieces became that. And notice anything times 0 is 0. So right here I'm left with
Root 3 over 2.
3 over 2. Okay? And then we do the same thing. Same thing on the bottom. Wait, yes?
Cosine 300 is 1.
Cosine 360 is 1.
Oh, why are we doing 360?
We use the angle difference here. 60 minus 360 is negative 300.
Oh, so you add whatever you were gonna subtract it from to make it.
I just came up with two angles that I knew values for that would make negative 300.
It doesn't have to be.
Oh,
But
okay.
yeah, negative 300.
What's that? Go.
Negative 300 is already.
Yeah.
I know negative 300 is already special, but we're using the identities to verify that. So today on your assignment, you can use, you would be able to look on your unit circle for a lot of the angles we're going to be calculating, but I expect you to show your work and apply these identities. Okay? Let's finish this problem, unless it's a question right here. Is there a question on this one?
It's about.
Let me finish this real quick. Cosine 60, we got 1/2 times 360, which is 1. Okay, so we get those two pieces, plus sine 60, which is root 3 over 2, and sine 360, which is 0. This part gives us 0, so I'm left with divided by 1/2, not negative 1/2, 1/2. Okay. And root 3 over 2 divided by 1/2 is the same thing as root 3 over 2 times 2. So that's root 3 over 2 times 2 over 2. They cancel. That's root 3. So yes, you could find that on the unit circle. You could find it in your special angles. However, I expect to see work for those. Okay, Alana.
For when you're doing the A and B terms, does that have to be those exact values?
Nope, you can use different values to find, and they would still give you the same answer.
Okay.
Hayden.
Oh, would it be root 3 over 2 times 2 over 1?
It would be, which would give you 2 root 3 over 2.
Oh, yeah, okay.
Okay. Samir.
So when you're set the, which is sine, yeah, there.
Right.
Do you have to use special angle numbers that we know?
That would be helpful if you're finding exact values. Yep.
What if we can't?
Then you can't use that identity. Correct. Okay. Okay. Any other questions? You guys are not covering all the identities this year. There are many more. Gee.
Like,
All right.
how many more?
All right. Your assignment